We're going to factor the polynomial x to the third minus 7x squared plus 4x minus 28. When we're factoring, we can think all of the options we have. So we can start with dots. Do we have a difference of two perfect squares? And this is not the case because we have 4 terms. The 4x is a perfect square, the x squared is a perfect square, but everything else is not a perfect square. And there's not a difference just between 2 terms. So we're not going to use the difference of 2 perfect squares. The next thing we're going to consider is there a greatest common factor? And we'll see here that because there's a 1 in front of x to the third, there is no common factor that we can pull out between 1, 7, 4, and 28. And then lastly, we can't pull out a common factor of x because the 28 is a constant and there's no x attached to it. So when this happens, when we have these 4 terms, we can think about using factoring by grouping. So I'm going to group together this x to the third minus 7x squared, and I'm also going to group together the 4x minus 28. So when I'm looking at x to the third minus 7x squared, I could think about factoring out the greatest common factor. There is no coefficient greatest common factor other than 1, so we're not going to factor anything out. But we can factor out an x squared from our variables. So if we factor out an x squared, we're left with x minus 7. So again, we can think about it like when we take an x squared out of the 3x, we're left with just x. And when we take an x squared out of negative 7x squared, we're left with just a 7. We can also think about distributing it back through where we would get x to the third minus 7x squared if we wanted to check our work. We're now going to consider the next 2 terms of our equation, 4x minus 28. And here, the greatest common factor between them is 4. So we can do plus 4, and parentheses, when I factor a 4x out of a factor of 4 out of 4x, I'm left with just x. And when I factor a 4 out of negative 28, I'm left with negative 7. And I'm going to rewrite this all in the same color now so we can see things more clearly. So x squared times x minus 7 plus 4 times x minus 7. And we should see something really cool happening here. The big noticing that we want to see is that we have in both of our terms x squared times x minus 7 plus 4 times x minus 7. We have 2 x minus 7s. So conceptually, this means now that we can actually completely factor out an x minus 7. So I'm going to factor out an x minus 7 from both terms. And when I factor out an x minus 7, I'm left with, in this situation, I'm left with an x squared plus 4. And we can see that here, x squared plus 4. So we're literally taking out the factor of x minus 7. And if anyone's having trouble conceptually seeing this, I can think about it as x minus 7 times x squared plus 4. I can distribute the whole x minus 7 as a parentheses into x squared. And I can write it as x squared times x minus 7. And then I can take my x minus 7 and multiply it by 4. And I can see that I'll have 4 times x minus 7, which would bring us back to this step that we had here. So my x minus 7 in pink cannot be factored anymore. And then I'm going to look at my x squared plus 4. And we can think, could this be factored anymore? X squared plus 4, is it a difference of 2 perfect squares? And they are 2 perfect squares, x squared and 4. However, it's not a difference, it's a sum. So this cannot be factored anymore. There is no greatest common factor. And we're not going to do x game with a trinomial because we have a binomial. Therefore, this is my final answer for the factored form of this polynomial.